Good afternoon, everyone. So you had one assignment कि how the Indian currents in the Indian Ocean are directly determined by the wind. कैसे लिखोगे? क्या था क्वेश्चन? The relationship between the wind and the current is properly seen in the Indian Ocean. Justify. ये चालू कैसे हो रहा है? थोड़ा आवाज कम कर. Lights. So the relationship between winds and ocean currents in the Indian Ocean. कैसे लिखोगे आंसर? In the Indian Ocean. कोई और आंसर? आंसर में ये स्टार्ट कि ओशन करंट के क्या क्या फैक्टर्स है. फाइन, दिस शुड बी वन पार्ट ऑफ एन आंसर कि देयर आर डिफरेंट फैक्टर्स सच एज कोरियोलिस फोर्स, रोटेशन ऑफ द अर्थ, विंड्स एक्सेट्रा प्रेजेंट. फाइन, and also the density and salinity differences. Then second point should be how Indian Ocean is different from the other oceans, that is how North Indian Ocean is different. So how it is different? It is not connected to the Arctic, and therefore third point, because it is not connected to the Arctic, density and temperature differences do not play an important role. That is, there is density and temperature differences does not play an important role, and therefore there is an absence of cold currents. There is no sinking, there is no current from the northern side. Fine, there is only warm current. Fourth, the typical current of the Indian Ocean, therefore unlike the other oceans, show seasonal reversal. ऐसे लिखना पड़ेगा, show seasonal reversal. Seasonal reversal मतलब सीजन्स के साथ वो चेंज होते हैं, एंड दिस सीजनल रिवर्सल इज ड्यू टू द विंड्स विच आर नोन एज मॉनसून विंड्स. फिर फिफ्थ पॉइंट डायग्राम, देन सिक्स्थ पॉइंट, देन यू एक्सप्लेन व्हाट इज द साउथ ईस्ट मॉनसून करंट. सेवेंथ, व्हाट इज द नॉर्थ ईस्ट मॉनसून करंट, कौन से सीजन में. एंड एट पॉइंट, but the normal current system is maintained in the southern Indian Ocean because it is connected to the Antarctic. Thus, unlike the other oceans where landmass, salinity, density, etc. plays an important role, here the most dominant role is by winds. Fine, getting it? ऐसे लिखने की कोशिश करो. So one thing, you take down some of the points regarding the Indian Ocean. लिखो, I am sharing. See, after your class yesterday I had a test discussion. Test discussion was till 8 o'clock. 7:30 से मैम के, विराज सर के कंटिन्यूस फोन आ रहे थे. मेरा फोन साइलेंट पे था, मैंने देखा नहीं. आई वेंट आउट एंड मनु के फोन पे फोन आया था ऑफ मैम कि My old friend, you know that person because he is one of the most famous teacher of Vision IS. Ethics he teaches, Dr. Suraj Suryavanshi, right? So, plus he, I'll tell you his story, is one of the most ethical person. Always was a merit student. In Maharashtra, there are two regions. In certain regions, Maratha caste is not given OBC. In certain regions, the Maratha caste is given the OBC. So initially, he had given the exam in the open category. Always good marks, always used to write the mains. Unfortunately, one attempt में, and he could not clear in that. So 2012 तक उसके attempt खत्म हो गए. Then he joined Rouse. Rouse से he came to Vision. Vision के starting में he was one of the leading players, and still he used to teach the ethics. 2015 में he got selected as IRS Customs. Yesterday he died in BLK. So you can see how life is so temporary. We used to tell him, बस हो गया राजेंद्र नगर के pollution से निकल जा, अकेले मत रहे, शादी कर ले. Why he died? Because nobody was, मतलब he was a doctor from Aurangabad Medical College, but he died because he was overconfident कि चलो कुछ नहीं, BP 222/160 normal है मेरे लिए, वो मैं हमेशा निकाल लेता हूँ. So चैतन्य सर, because उनके 2 साल जूनियर थे, चैतन्य सर who is also here, तो चैतन्य सर उनको हॉस्पिटल ले गए, and unfortunately गंगाराम से he got transferred into BLK. Why? Because empanelment था. चैतन्य was saying empanelment तो सब छोड़ो, नहीं नहीं मेरे मम्मी डैडी आएंगे तो उनको BLK ज़्यादा नज़दीक रहेगा, वो सब इसमें 1-1.5 घंटा चला गया. And as soon as he was admitted to BLK in ICU, within 2-3 minutes he got a severe heart attack and he died. So you see so much struggle in life. 2015 में post मिला, and 2015 में post मिलने के बाद he took 1 year का extension to get into IAS. So he did not join in 2016, he joined in 2017, first posting in Delhi, and ultimately life is so temporary. That is why जो कुछ हम करेंगे यहाँ पे, do it very sincerely, but you should also know that there are some other parts also. The only son, mother is saying कि mother and father did not knew, they came, everyone was there, our entire staff Vision was there, entire customs was there in BLK. So but mother का एक statement मुझे बहुत जो hurt अंदर से लगा, वो था कि you took birth only to study, never to enjoy life. You never enjoyed life. डॉक्टर की पढ़ाई की, डॉक्टर के बाद यूपीएससी की पढ़ाई की, और जब सब कुछ मिला देन लाइफ चली गई. ऐसे मत करो. 30 तक जी जान लगाओ. अगर होता है यहाँ पे वैसे जी जान लगाओगे तो होगा ही, नहीं होता कुछ बुरा नहीं मानना है. यू शुड चेंज, you should enjoy. And he had talked to me 10 days back ki what life I am living. At this age I should have wife, I should have kids, I should be enjoying their birthdays, I should be celebrating. But you see, this is not what, and all of UPSC aspirants do the same mistakes. And when they get into very late, they start realizing कि ये सब अंदर से खोखला है, जो बाहर से दिखता है अंदर से सब खोखला है. Right? That is what I want you to know कि अभी जो कर रहे हो seriously करो, because so temporary is the life. See, everything has been achieved, but ultimately life ही नहीं बची. And you know him because उनके videos Vision IS में सबसे ज़्यादा ये है, and only officer who teaches in Vision IS. मैम के first student when ma'am started coaching in Mukherjee Nagar, he was the first student. So जो भी assignments है, जो कुछ ये है, because you see you come to my age, I can understand your importance is there, but this year I had decided first priority is family, second priority is students. Last year तक my priorities were different. अब my priorities have changed. First priority is my kid. and then second priority is wife, third priority is students. क्योंकि health ये जो है, it is all अगर ऐसा ही रहा, that is why I keep on telling you you should prioritize in life. क्या चाहिए आपको, क्या नहीं चाहिए. I was talking to one of the very old friend today, common roommate, never cleared UPSC prelims, one of the worst students of UPSC. फाइन, हम लोग उसको अवॉइड करते थे. आई टोल्ड हिम सूरज एक्सेट्रा हैड, और वैसे ही बातें बातें गई. एंड डू यू नो ही पेड द इनकम टैक्स ऑफ 13 करोड़ रुपीज दिस ईयर. नहीं हुआ यूपीएससी, क्या फर्क पड़ा. बिजनेस सेटअप किया, उसका दिमाग उसमें था. इन लास्ट 4 years his business is so strong that his company का turnover is around 260 crores per year. Fine. So ये किसके लिए है सबसे ज्यादा, उनके लिए है those who have age. UPSC is giving you age till 35, UPSC is giving you age till 39. 30 के बाद बिल्कुल नहीं. 30 should be the end. Getting it? So 30 तक जितनी जी जान लगा सकते हो लगाओ यूपीएससी में. उसके बाद इफ नहीं होता, मेरे को ज्यादा फर्क नहीं पड़ा. ऑब्वियसली थोड़ा बहुत ब्रेकअप्स हुए, थोड़े बहुत टीचिंग ब्रेकअप्स, मतलब दोस्तों के साथ, वैसे ब्रेकअप नहीं. थोड़ा बुरा लगा. बट आई टेल माई फ्रेंड्स जो अभी भी स्टेट सर्विसेज दे रहे हैं, दैट यू शुड फाइंड एन अल्टरनेटिव एम्प्लॉयमेंट, बिकॉज लाइफ विल नॉट वेट. एंड yesterday was a lesson for that. So because see, what is the worst thing for the parents is to see children die. That is the worst thing for the parents. मॉम को लगा कि ऐसे ही बेटे ने बुलाया. शी केम टू BLK, थैली निकाली जिसमें खाने पीने का था, सब कुछ था, एंड अंदर डेड बॉडी थी. शी रीच्ड एट अराउंड 2 o'clock और सब इन द नाइट. सो दैट इज द वर्स्ट थिंग. तो ये इसलिए भी कह रहा हूँ क्योंकि देयर आर सम स्टूडेंट्स हु गिव मोर देन इम्पोर्टेंस टू मेनी थिंग्स, मोर देन लाइफ. सबसे पहले लाइफ में अब आप कौन से स्टेज में हो, यू आर इन द स्टेज ऑफ विद्यार्थी. दैट इज यू शुड टेक द नॉलेज, यू शुड वर्क हार्ड, बट यू शुड ऑल्सो लुक एट द अदर थिंग्स. अगर नहीं हो रहा है पैरेलली, बट अटक के नहीं रहना है किसी चीज में ना. वो चाहे वो कोई रिलेशनशिप हो, चाहे वो कोई, इवन दिस इज अ रिलेशनशिप विद यूपीएससी. होता है तो होता है, नहीं तो डिच करेगी यूपीएससी. ज्यादा से ज्यादा क्या है, यू हैव टू फाइंड समथिंग एल्स. यूपीएससी नहीं तो स्टेट सर्विसेज, अगर वो नहीं तो, बट ट्राई हमेशा फुल फ्लेज्ड होना चाहिए. ससुर को मिलके ही आना चाहिए, मतलब इंटरव्यू तक जाना ही चाहिए. फाइन. इफ दैट डज नॉट ऑकर, देन यू शुड नॉट, देन यू आर मिसिंग समथिंग. बट दिस इज देयर. प्रीलिम्स फेल होना ही नहीं चाहिए, because this is very passing. You never know कि अगले 10 साल में क्या होने वाला है. I can give you numerous such examples. Fine. So होम स्टेट मिला, आईपीएस बना, पर कैंसर ही निकल आया आईपीएस बनते ही. I have many such examples. That is why चलते रहो. Fine. Coming to the Indian Ocean. We have drawn the diagram. Fine. So introduction. The Indian Ocean, which is the third largest ocean, the Indian Ocean, which is the third largest ocean, is unique. In the sense that It is not connected to the polar Arctic region. It is not connected to the polar Arctic region in the northern hemisphere. In the northern hemisphere. And hence a gyre मतलब कोल्ड करंट, वार्म करंट जो गोल बनाते हैं, अ गायर और सब ट्रॉपिकल गायर, subtropical gyre is absent in the North Indian Ocean. Is absent in the North Indian Ocean. Next point. Out of numerous factors forming the ocean currents, out of numerous factors forming the ocean currents, density differences due to temperature gradient, density differences due to temperature gradient, understanding temperature gradient मतलब cold and warm current is absent. Wind plays the most important role in origin. Wind plays the most important role in origin of surface ocean currents, and land masses play the most important role in modification. And land masses play the most important role in modification. फिर से पढ़ो statement. Wind in origin, land masses in modification. Land masses do not originate the ocean currents, they will modify the direction of the ocean currents. Getting it? Wind plays the most important role in origin and the land masses in modification. Next point. Have we written there is absence of cold current? Here? No. There is absence of cold ocean currents. There is absence of cold ocean currents in the northern Indian Ocean. Absence of cold ocean currents in the northern Indian Ocean. As well as of thermohaline circulation. Of thermohaline circulation. Understand what is thermohaline circulation? Circulation of water below meters. मतलब thermohaline layer. Halocline या thermocline layer. Thermo temperature. Haline salinity. 500 से 1000. 500 से 1000. किसमें? इंडियन ओशन में थर्मोहालाइन सर्कुलेशन क्यों एब्सेंट है? बिकॉज कोल्ड करंट्स नहीं है. कोल्ड करंट्स नहीं है तो डाउन वेलिंग नहीं है. डाउन वेलिंग नहीं है तो इसलिए एब्सेंट है. हाँ 1 डिग्री सेल्सियस। अब सर्कुलेशन कौन से वाटर का होता है? सर्कुलेशन कौन से वाटर का होता है जिसका टेम्परेचर इज इवन 1 डिग्री सेल्सियस, जिसका डेंसिटी इज डिफरेंट. डेंसिटी इज नॉट डिटरमाइंड जस्ट बाय टेम्परेचर, डेंसिटी इज ऑल्सो डिटरमाइंड बाय सैलिनिटी. सो नीचे का टेम्परेचर भी सेम अगर रहेगा फिर भी डेंसिटी अलग हो सकती है ड्यू टू कंटेंट ऑफ सॉल्ट. सो कोल्ड पोलर वाटर सरफेस पे तो बहुत ज्यादा क्लियर है, इट इज स्वीट, but below the surface because of the ice formation and the rejection of salt brine, नीचे का पानी बहुत ज्यादा कोल्ड एंड सलाइन होता है. दो टेम्परेचर उसका 1 डिग्री है, इक्वेटर का भी 1 डिग्री है, वो ज्यादा सलाइन है, इसीलिए नीचे से ऐसा सर्कुलेशन जाता है विच इज नोन एज एन थर्मोहलाइन सर्कुलेशन. नेक्स्ट, the relationship between winds, the relationship between winds and ocean current is best understood in the northern Indian Ocean, best understood in the northern Indian Ocean because sub point during the southwest monsoon season, the ocean current is from southwest to northeast. Right? This ocean current जो मैंने कल बताया था वही है. This ocean current is further divided into Arabian Sea branch and the Bay of Bengal branch. This ocean current is further divided into Arabian Sea branch and the Bay of Bengal branch. Is the monsoon wind divided into Arabian Sea branch and the Bay of Bengal branch? Monsoon ki wind? Yes. So ocean current is also divided into the Arabian Sea branch and the Bay of Bengal branch. During this season, counter equatorial current is absent. और यहाँ पे वो समर वाला डायग्राम आना चाहिए. In this point, after this point, there should be that summer wala diagram. Absence of counter equatorial current, etc. What we have drawn yesterday. Is absent. The diagram which we have drawn yesterday should come here, in which we show this one. Southwest monsoon current, Arabian Sea branch, Bay of Bengal branch, and then ऐसे. There is no counter equatorial current. Getting it? Next point. During the northeast monsoon season, similar to the winds, there is complete reversal. Underline the word complete reversal. Similar to the winds, there is complete reversal in the direction of ocean current. Complete reversal in the direction of ocean current. And the northern Indian Ocean develops northeast monsoon current. Northern Indian Ocean. नॉर्दर्न इंडियन ओशन, सदर्न इंडियन ओशन तो इक्वेटर के नीचे है. Develops northeast monsoon current which flows in northeasterly direction. कोई जरूरत नहीं इसकी. नॉर्थ ईस्ट मानसून करंट ऑब्वियसली फ्लोज इन द नॉर्थ ईस्टर्ली डायरेक्शन है. फाइन. नेक्स्ट पॉइंट. इन द सदर्न इंडियन ओशन, in the southern Indian Ocean, the subtropical gyre, the subtropical gyre, subtropical gyre मतलब ओशन करंट्स को subtropical gyre भी कहते हैं, is similar to the other oceans, is similar to the other oceans because it is connected to the Antarctic, because it is connected to Antarctic, because it is connected to the Antarctic. Next, thus due to the location, shape, size, Indian Ocean sees seasonal reversal of winds as well as ocean currents. Sees seasonal reversal of winds as well as ocean currents. Sees the seasonal reversal of winds as well as the ocean currents. Right? Any doubts? This is how the answer should be. Answer में थोड़ा technicalities होनी चाहिए. पहले क्या क्या factors है, thermohaline circulation बता दिया. Then you have mentioned कि there is a seasonal reversal of wind. Specifically पूछा है, justify. So seasonal reversal of wind कैसे होता है, and therefore how the ocean current changes, and compare कर लिया उसको बाकी के oceans के साथ कि बाकी के oceans में ऐसे ऐसे होता है. Fine? काउंटर इक्वेटोरियल करंट होगा बिकॉज विंड्स यहाँ पे जाके चेंज होगी. काउंटर इक्वेटोरियल करंट हमेशा ऐसा है. काउंटर इक्वेटोरियल है. काउंटर इक्वेटोरियल करंट इन इंडियन ओशन इज प्रेजेंट ओनली इन द विंटर्स, नॉट इन द समर सीजन. राइट? यस. और ये दो डायग्राम्स आपके आने चाहिए. क्लियर विद दिस? अब इस आंसर को और अच्छा बना सकते हो तो यू, दैट इज चॉइस इज योर्स कि अगुलास करंट कैसा है, या जनरल आइडिया दे दिया पहले ओशन करंट्स ऑफ द वर्ल्ड का एक डायग्राम, फिर इंडियन ओशन का नॉर्थ समर्स में क्या है, विंटर्स में क्या है, दो डायग्राम्स. फाइन? गेटिंग इट? अब the next point I want to ask you is the importance of the ocean currents or significance of ocean currents. Very simple. Don't write anything, just tell me the points. अगर ओशन करंट्स नहीं होते तो क्या क्या होता? तो can I say excess heat from the equator is transported to the poles and the polar colder water is brought to the equators, thus helps in maintaining the balance. Fine. So understanding, it helps in, can I say, maintaining the balance. दूसरा importance, fishing industries. Why? Mixing, बस mixing से या upwelling which brings the nutrients. Third importance, Can I say major ocean routes are determined on the basis of ocean currents? That is the navigation. Major ocean routes are determined on the basis of ocean currents. Fourth, fourth, prediction कैसे, how will you do? Fourth importance of ocean currents, fishing हो गया, कैसे? British type of climate due to warming effect of ocean currents. We have cyclones intensification due to Gulf streams or warm currents, or due to जहाँ जहाँ cold currents है, we do not have tropical cyclones, absent. Fine. बहुत general cross मतलब absent. या heat waves generate करेंगे in the cities such as New York due to the warming effect of the Gulf stream. Fine. Temperature inversion होगा due to mixing. Mixing से temperature inversion होगा. That is, will the warm and cold ocean currents mix? So will there be fogs? Yes. Inversion. Navigation को ocean routes and जहाँ जहाँ temperature inversion है वहाँ पे क्या, can I say there will be sea accidents? क्योंकि दिखेगा नहीं. नहीं समझ में आ रहा है तो सिर्फ अभी ये पॉइंट समझ लो. Why sea accidents? If this is the ocean current, fine. If there is a warm ocean current which is going here, and if the cold ocean current is coming here, and this is a continent, so the cold and warm ocean currents जहाँ meet होते हैं वहाँ पे there is the formation of fogs. Why fogs? Just remember, cold air नीचे आएगी, warm air ऊपर जाएगी. The cold air will cool the warm air from below. Water droplets will, water vapor will be converted into water या ice, low lying cloud, fog. But ये जो cold ocean current है which is coming downwards, it is bringing large amount of icebergs, और fogs होने के बाद this icebergs cannot be seen, and therefore Titanic का accident. This is the region जहाँ पे Titanic जैसे accidents are very very common. Fine. And can I say ocean currents can be used to generate energy? Yes. You will not find all these points in the Savindra Singh. इसीलिए just remember, that is why I am carrying this book today, and you have this book on the this thing. कोई करने की ज़रूरत नहीं book में से, but these are the photos of the turbines below the ocean currents, below the oceans. जैसे winds will rotate the turbines on the land, ocean currents will rotate the turbines in the water bodies. Getting it? So you have this book, and this is the page number 250 of the book, जिस पे वो photo है. You have the edition, latest edition of this book on the Telegram. Fine, on our this thing. और ये जो दिख रहा है, that is our next topic of study. दिख रहा है कुछ गरम रेड कलर, कुछ ठंडा. This is what is thermohaline circulation. यहाँ से है यहाँ तक पैसिफिक में है. The only thing which is absent thermohaline circulation is Northern Indian Ocean. Getting it? Thermohaline circulation is absent. So before I go, I am not going to dictate you answer today. Go home, search on the net कि what are, या फिर just remember this point, direct लिखने की कोशिश करो. The only thing I am saying is, rather than कहीं search मत करो, सिर्फ सविंद्र सिंह उठाओ, सविंद्र सिंह में से उठाओ points लो, जितना डायग्राम बना सकते हो उतना बनाओ, जितना यू कैन बी क्रिएटिव उतना रहो, जितने रिसेंट एग्जांपल्स ले सकते हो लो, and just divide your answer into, just see how I am dividing the answer. Weather, weather, weather. So significance of ocean currents on weather and climate. Fine. Economy, that is on fishing. Second point. Why? गल्फ स्ट्रीम का डायग्राम, एंड थर्ड नेविगेशन, एंड कंक्लूजन में एनर्जी, रिन्यूएबल एनर्जी या नॉन कन्वेंशनल एनर्जी. द सिग्निफिकेंस ऑफ ओशन करंट विल कम इन 4 पॉइंट्स. वेदर एंड क्लाइमेट, उसमें ये सारा एक डायग्राम नॉर्थ अटलांटिक ड्रिफ्ट का, वन एग्जांपल ऑफ व्हाट इज द साइक्लोन राइट नाउ रिसेंटली, ऐसे करंट के एग्जांपल लेने, व्हिच इज द व्हाट इज द नेम ऑफ साइक्लोन दैट इज हरिकेन दैट इज इन यूएसए, डोरियन. डोरियन का एग्जांपल यू कैन पुट, गल्फ स्ट्रीम वाला रीजन. फिशिंग, show the mixing of warm and cold ocean current, that is the Gulf Stream and Newfoundland region, Labrador, and बताना क्यों. And third, navigation. Ocean routes अगर जिसको दिखाने हैं, that is given in your atlas, but वो थोड़ा difficult हो जाएगा, so forget about that. But accidents and major ocean routes, fine. And nowadays the ocean currents also help in energy generation by putting the turbine similar to the wind energy. Extra point, energy generation. Conclusion of such answers, don't worry about the conclusions. Direct questions है ये, इनके conclusions नहीं रहेंगे तो भी चलेगा, या अगर लिखना है तो 10 the mixing of cold and warm ocean currents, या 10 the dynamics of ocean water in the form of waves, ocean currents and tides has an important impact on climate, biodiversity as well as humanity. Getting it? या कुछ भी, any conclusion. So will you write it? Right? Show it to me tomorrow. The significance of the ocean currents. Now I am coming to a very important topic, that is what is known as an Ekman circulation. Now those who don't know climate, and even those who know the climate, you know winds always flow from low pressure to high pressure to low pressure. Why? Because wind is attracted by a force that is known as an pressure gradient force. So pressure gradient force, that is the difference in the pressure conditions, always acts from low pressure to high pressure. So can I say this is the direction of pressure gradient force? कंसेप्ट है ये, एग्जाम के लिए इतना इंपॉर्टेंट नहीं है शायद. नो क्वेश्चन हैज कम टिल नाउ एक्सेप्ट वंस ऑन द एकमैन स्पाइरल, बट इट इज व्हाट आई टोल्ड यू, 230 से 290 तक जाने वाली चीज है ये. एंड वैल्यू एडिशन, योर आंसर शुड रिफ्लेक्ट दिस. प्रेशर ग्रेडियंट फोर्स ऑलवेज एक्ट्स फ्रॉम हाई प्रेशर टू लो प्रेशर, देयरफॉर विंड ऐसे सीधी जानी चाहिए. Theoretically, wind flows from high pressure to low pressure, but wind, why? Because the pressure gradient force is acting in this. So theoretically, wind, if there is only one force, wind should flow straight, right? But there is not only one force, there is also another force that acts on the winds, and this acts perpendicular to the pressure gradient force, and we will call this force as the Coriolis force. Coriolis force हमेशा act करेगा perpendicular to the pressure gradient force, fine. And therefore दोनों के बीच the direction of the wind will be in दोनों के बीच, that is wind may flow from high pressure to low pressure but somewhat in this direction. This is the direction of the winds, neither straight, neither in the direction of the Coriolis force, दोनों के बीच 45 degrees में. You see westerlies, easterlies, all are, therefore we say the winds are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. Winds के साथ साथ does the ocean currents also start moving? अब पूरा ध्यान से सुनना. So ocean currents also start moving in this direction like wind, but the problem in the ocean currents is ऊपर का part comes in the direct contact with the wind, उसके नीचे का पार्ट comes in the contact with upper water which is slightly less denser, उसके नीचे वाला पार्ट which is more denser does not come into the contact directly with the wind, but direct comes in the contact with the water. And as a result of this, what at some places, hamesha nahi, at some places generally ocean currents flow more or less perpendicular to the wind direction. So these are the forces. मेरे को अभी उसकी ज़रूरत नहीं है, मेरे को इस high pressure low pressure की ज़रूरत नहीं है. Just know this is the direction of the wind and this is the direction of the ocean current at some places perpendicular to the wind direction. Nobody asked me a doubt कि हम ये diagram क्यों बना रहे हैं. Fine? I am not. West wind drift. West wind drift ऐसे क्यों आ रही है? As Benguela current, as Humboldt current, as West Australian current, ऐसे क्यों ऊपर की तरफ? Now understanding Ekman spiral, this is the direction of westerly winds, and ocean currents will always flow perpendicular to the wind direction at some places. इसीलिए cold ocean currents ऊपर की तरफ आते हैं. या therefore cold ocean currents, Kuroshio currents come southwards. Why? Because यहाँ पे the direction of the wind is westerly wind drift. That is, understand, winds when they go from the lower latitudes to the higher latitudes, unka deflection increases. What is the westerly winds? The winds that flow from west to east. So वो start होती है somewhere around 30 degree north and south. It gets deflected to the right in the northern hemisphere. जितना वो polar regions की तरफ जाएगी उतना deflection बढ़ेगा. And ultimately in the polar regions they will flow from west to east. Getting it? So इसीलिए there is a west wind drift, and because of the west wind drift we see some of the cold currents flow from higher latitudes to the lower latitudes, जो मैंने आपको diagram दिखाया. Getting it? Perpendicular to the wind direction. This was discovered by Sir Ekman, and therefore it is known as an Ekman spiral. Ekman spiral is the reason why at some places there will be downwelling, why at some places there will be upwelling. क्यों किसी ने नहीं पूछा कि what is the reason कि cold current ऊपर क्यों आ रहा है, उधर ही क्यों नहीं रह रहा है नीचे? सरफेस वाटर निकल गया. क्यों है थर्मल इक्विलिब्रियम? क्यों है थर्मल इक्विलिब्रियम? स्पेस क्रिएट होता है तो लेक में भी होता है, तो लेक में क्यों नीचे का पानी ऊपर नहीं आता? नदी में क्यों नीचे का पानी ऊपर नहीं आता? आपने निकाल दिया इतना अपवेलिंग जैसा नहीं होगा. अपवेलिंग का वीडियो देखो कभी. अपवेलिंग इज इन ह्यूज एनॉर्मस क्वांटिटी. ऐसा नहीं है कि वैसे तो यहाँ का पानी भी मैंने ऊपर का पानी निकल गया तो नीचे का पानी ऊपर है, उसको मैं अपवेलिंग नहीं कहूंगा. अपवेलिंग इज इन द ह्यूज वॉल्यूम. That is because Ekman spiral again. मतलब now you will understand what is upwelling, what is downwelling, and उसमें क्या याद रखना है GS के लिए? अपवेलिंग के क्या फायदे हैं, डाउनवेलिंग के क्या फायदे हैं. ऑप्शनल में क्यों हो रहा है ये? अंडरस्टैंडिंग? GS के लिए तो Ekman was physicist only. Not all geographers are physicists. तो उसने ये जोग्राफर्स को बताया कि ऐसे ऐसे होता है थर्मोडायनेमिक्स के कारण. बट यू आर फिजिसिस्ट, नॉट द क्लास. तो वो कैसे बताना है? दैट इज एकमैन स्पाइरल. यू कैन नॉट राइट कि थर्मोडायनेमिक्स will cause. No geographer will understand that thermodynamics will cause. Getting it? So Ekman was a physicist only. So coming to the Ekman spiral. That is, question is examine how winds and Coriolis force result into transportation of the ocean currents. Transportation of the ocean currents. Fine, कुछ नहीं, just a physics. This is all you know in simple language job जहाँ तक हमने किया है, but we are going to do in the physical language. So this people say, the geographers say that winds Coriolis force will result into three kind of circulation of the ocean currents. One is the Ekman circulation, one is the westerly intensification, and third is subtropical and subpolar gyre. Yeah, gyre in the ocean. So the first point, the dragging by the wind, comma, pressure gradient and the Coriolis force. Pressure gradient and the Coriolis force causes three types of circulation. First, Ekman's spiral, second, circulation gyres, and third, western boundary intensification. Third is western boundary intensification. Don't get afraid by the words. ये सब simple है except for the Ekman transport. What is Ekman transport आपको पता नहीं है, but you already know what is the gyre, warm currents, fine, and then cold currents. This is what is the gyre, circulatory motion. Western boundary intensification क्या है? You already know that both the equatorial currents will come and as a result of this they will converge, and due to convergence यहाँ पे पानी का level बहुत ज़्यादा बढ़ जाएगा. This will result into smaller counter equatorial current. So कहाँ पे ज़्यादा हो रहा है पानी? Western boundary of oceans. Obviously हमें क्या पढ़ना है? सिर्फ Ekman transport, not the gyre. Gyre मतलब क्या? Circulatory motion. Fine. Western boundary intensification मतलब क्या? कि both the convergence of both the warm and cold currents will result into both the convergence of north and south equatorial current will result into piling up of water here, which will cause the counter equatorial current to flow back. This is what is known as the western boundary intensification. Getting it? Any doubts? So Ekman transport. What to prepare for the Ekman transport? Just prepare it for the short notes. You say, who is the father of USA? What is the importance of Benjamin Franklin in USA? Benjamin Franklin. और दूसरा what? Penicillin. Alexander Fleming. Benjamin Franklin, lightning से. Then he was one of the first person to write the constitution properly of USA. And thirdly, he was the person who discovered Gulf Stream. Gulf Stream was discovered by the Benjamin Franklin. मैंने क्यों बोला ऐसे ही, जो ऐसे ही एक मैन था. जैसे बेंजामिन फ्रैंकलिन was a politician who did the experiments with the lightning and who also discovered also became a geographer. Similarly, Ekman was just a physicist and he gave the circulation कि क्यों नॉर्थ अटलांटिक ड्रिफ्ट ऐसे क्यों आता है यूएसए की तरफ, क्यों नहीं चला जाता along with the westerlies. That is what is known as an Ekman transport. Getting it? क्योंकि westerlies तो ऐसे ऐसे जा रही है, ओशन करंट नॉर्थ अटलांटिक ड्रिफ्ट ऐसे क्यों हो रहा है? Why it is coming this way? The easterlies are moving in this manner. Why it is coming in this manner? Getting it? So this is what is the Ekman spiral or Ekman's transport. So Ekman was a Swedish physicist. Who developed a circulatory movement, who developed a circulatory model of ocean currents, known as Ekman's spiral. This circulatory model of the ocean currents was developed on the basis of variation in the speed, density, and the depth, variation in the speed, density, and the depth of ocean currents. Depth of the ocean currents. Why we study this? Understand, ये model revolutionized the way we do the transport. This is the direction of the wind. पहले लोगों को लगता था जिस डायरेक्शन में विंड है उसी डायरेक्शन में आइसबर्ग मूव करेगा. Imagine this is a three-dimensional, wind is going from all this direction and therefore boat इस direction में जा रही है. बोट वाले को लगेगा, the ship को लगेगा, this iceberg is not going to affect me. But Ekman ने कहा ocean currents always will flow perpendicular to the direction of the wind, and ocean currents के direction में always the icebergs will flow. That means as per the Ekman spiral, this iceberg is going to directly hit the ship and thus it may destroy the ship. That is why Ekman spiral is important ocean routes के लिए. Understanding? Wind ऐसी जा रही है, ship is also going in this direction, it sees an iceberg. When it sees an iceberg, it is not worrying about the iceberg, but as the wind is going here, this iceberg will travel and ultimately it may hit the ship. So किस direction में iceberg is going to come, it depends upon the direction of the wind, उसके perpendicular में, because nobody is going to see the ocean current, it is always going to see the direction of the wind, उसके perpendicular में always the icebergs will come. Getting it? वही हम पढ़ने वाले हैं, ऐसा क्यों? That is what is the Ekman's spiral. ओशन करंट्स को ऐसे देखेगा. आजकल के शिप्स में कैप्टन विंड को देखते हैं एंड मैग्नेटिक फील्ड को देखते हैं, बाकी किसी को नहीं. टेक्नोलॉजी हैज गॉन टू सच एन एक्सटेंट दैट इन सब की किसी की ट्रेडिशनल विंड्स you cannot see ocean currents in the oceans properly. वी कैन नॉट सी, इसलिए चलो जीरो, कुछ नहीं पता. व्हाट इज एकमैन स्पाइरल? ओशन करंट्स विल ट्रैवल इन द परपेंडिकुलर टू द विंड्स. खत्म. आइसबर्ग विसबर्ग भूल जाओ. मैंने आपको सिर्फ इंपॉर्टेंस बताना था मुझे. नेक्स्ट पॉइंट. Point, take it in the point. Ekman spiral describes that speed and the direction. Ekman spiral describes that speed and the direction of surface ocean currents. Speed and the direction of the surface ocean currents. Experiences variation in the velocity variations along with the depths. Experiences variation along with the depths. Speed and the direction of ocean currents experiences variation along with the depths. Along with the depth. Should I repeat the point again? Speed and the direction of the surface ocean current experiences variations along with the depth. बाकी का points cancel करो. Next point is, as the wind flows, due to the Coriolis effect, the immediate surface water starts flowing at 45 degrees. Starts flowing at 45 degrees to the direction of the wind. Starts flowing at 45 degrees to the wind direction. Starts flowing 45 degrees to the wind direction. Understanding the same first point, wind जिस direction में जा रही है उस direction में surface water will move at the 45 degrees. Second point, therefore the ocean currents are deflected. Therefore the ocean currents are deflected to the right in the northern hemisphere. Ocean currents are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. And to the left in the southern hemisphere. देखो ये डायग्राम बनाओ मत, अभी पूरा डायग्राम मैं बनाऊंगा तब बनाना. This diagram shows that 0 meter of the sea water, 100 meters of the sea water. This is what is the wind direction. जो surface water है, सिर्फ surface का water, 2 मीटर 3 मीटर का water, it is moving at 45 degrees. But surface का water you always should know that it is less denser as compared to the subsurface water. यहाँ का water is less denser as compared to the नीचे का water. Because this water is less denser, इसका speed will be different, and when the speed is different, deflection or the Coriolis effect is different. But as we are going deeper, the speed decreases due to density and therefore deflection changes. As the deflection changes, subsurface water किसी और direction में जाएगा, उसके नीचे का water किसी और direction में जाएगा, and therefore if this is the wind direction, this will be the direction of the ocean current in the form of Ekman's transport. I will complete this diagram till the time you write the answers. Understanding? This diagram is incomplete. This is the wind direction, this is the direction of Ekman transport, and you will see how surface water, subsurface water will keep on moving. Next point. क्या? No, no. Higher the velocity, greater is the deflection. Higher the velocity, greater is the deflection. Velocity of wind की हो सकती है, velocity ocean currents की हो सकती है, velocity किसी की भी हो सकती है. Density पे depend नहीं करेगा. Coriolis force does not depend upon density, but Coriolis force does not affect to water. Water depends upon density, and इसीलिए there is a problem of Ekman spiral. Clear हो जाएगा कुछ points के बाद. Density speed को affect करेगा, Coriolis force को affect करेगा. देखो, Coriolis force is not affected by speed, but the speed affects the Coriolis force. Wind का speed is determined by the pressure gradient force. What is the difference between high pressure and low pressure? जितना ज़्यादा difference of high pressure and low pressure, उतना greater will be the wind का speed. जितना greater is the wind का speed, उतना greater will be the deflection. Getting it? So, wind speed, velocity, deflection, Coriolis force. But इसका मतलब ये नहीं है कि जहां ज़्यादा deflection है, वहां पे wind की speed ज़्यादा है. समझ में आया? उल्टा नहीं है. Speed, Coriolis force is high, but जरूरी नहीं that Coriolis force high मतलब speed is high. Wind, climate में सब चीजें समझ में आ जाएगी. Coriolis force किसको अप्लाई होता है? Wind को. Wind किसको अफेक्ट कर रही है? पानी को. इसीलिए, बट वहां पे Coriolis force अफेक्ट नहीं करेगा, इसलिए एक नया थिंकर आया, Ekman spiral. Getting it? Next point. Thankfully अभी तक आया नहीं है क्वेश्चन, but we should be prepared for the worst. Next point. The thin layer of surface water, moves over the deeper layers of water. Moves over the deeper layers of the water. Moves over the deeper layers of the water. Full stop. Thus, the deeper layers are set in motion. Deeper layers are set in motion. ऊपर का पानी मूव कर रहा है, इसलिए नीचे का पानी भी उसके साथ साथ अब मूव करना शुरू हो जाएगा. This is what deeper layers are set in motion. Next point. This deeper layers, थोड़ा लंबा हो जाएगा आंसर because I am making the language easy. Right? This deeper layers will move with lesser velocity. Tell me why. Density या friction. जितना नीचे जाओगे उतना ज्यादा पानी, जितना ज्यादा पानी डेंसर उतना ज्यादा फ्रिक्शन, जितना ज्यादा फ्रिक्शन उतनी लेसर वेलोसिटी. यहां पे फ्रिक्शन नहीं है क्योंकि ऊपर हवा है. अंडरस्टैंडिंग दिस? विल मूव विथ लेसर वेलोसिटी ड्यू टू फ्रिक्शन कंज्यूमिंग एनर्जी. फ्रिक्शन कंज्यूमिंग एनर्जी. Friction consuming energy. Friction consuming energy means जो energy which is given by wind to the layers, ऊपर का layer will give that energy to the lower layer, but lower layer में friction will take the energy. या simple words में अगर नहीं समझ में आ रहा है तो due to friction. Fine. Next point. The frictional force of the wind, affects the water up to the depth of 100 meters. Understanding why we have made in the diagram? Up to the depth of 100 meters. Frictional force of the wind will affect the water up to the depth of 100 meters. Does the wind ka speed depends upon latitudes? Right? Understanding up to the depth of 100 meters. सिर्फ 100 meters का तक ही frictional force. So waves की maximum depth क्या है? Waves are generated due to friction. क्या? 100 meters. Tsunami is due to tectonic forces. Waves and tsunami इतना difference है कि waves में सिर्फ surface water ऊपर नीचे जाएगा, tsunami में entire ocean will come up and go down. Getting it? What happened? हाँ, entire ocean. पहले पूरा ocean will go and come up. Next point. ये जाएगा इसके 45 डिग्रीज में, डिफ्लेक्ट होगा. इसने शुरू किया नीचे के पानी के मूवमेंट, वो इसके 45 से कम इसमें, क्योंकि नीचे वेलोसिटी ज्यादा कम है ड्यू टू फ्रिक्शन, ये भी डिफ्लेक्ट होगा बट लेस देन 45 डिग्रीज. उस ये मूव करेगा तो उसके नीचे का पानी भी मूव करेगा, ये भी डिफ्लेक्ट होगा बट ऑब्वियसली लेस देन 45 डिग्रीज. दिस विल डिफ्लेक्ट बाय 20 डिग्रीज, दिस विल डिफ्लेक्ट बाय 15 degrees, this will deflect by 10 degrees, and ultimately 45 plus 20 plus 15 plus 10 will become 90 degrees, and thus pura water will move by 90 degrees. Understand now. Coriolis force depends upon velocity, मतलब deflection depends upon velocity. जहाँ velocity ज़्यादा है वहाँ पे deflection ज़्यादा है. Velocity wind के कारण surface layer थोड़ा ज़्यादा deflect हो गया. कितने डिग्री से? 45 डिग्री से. अभी सरफेस लेयर चलने लग गया तो इसके कारण नीचे का लेयर भी मोशन में आया, बट विद द वेलोसिटी ऑफ द सरफेस लेयर और लेसर वेलोसिटी? विद द वेलोसिटी ऑफ द सरफेस लेयर और लेसर वेलोसिटी? लेसर वेलोसिटी. व्हाई? बिकॉज इट इज डेंसर. as it is moving with lesser velocity, there is less deflection, because now the intermediate layer is moving, 100 meters wala layer will also start moving, but obviously with lesser velocity and therefore less deflection. So surface water, नीचे का water, this will all move in the form of spiral. जैसे पत्ते लिए किसी ने और पत्ते खोल दिए, ऊपर का लेयर, फिर नीचे का लेयर, फिर नीचे का लेयर, फिर नीचे का लेयर. अगर if you take the playing cards in hand and if you try to open up, this is how the direction of the ocean currents will be. ऊपर का layer will move with different speed, नीचे का layer, and thus the entire water will move at 90 degrees to the wind direction, and this is what is known as an Ekman spiral. Getting it? Next point. What was the point I dictated? Thus the successive layers will move with lesser velocity, but are deflected to the right of upper layer. To the right of upper layer in the northern hemisphere. Deflected to the right of upper layer in the northern hemisphere, and to the left of upper layer, in the southern hemisphere. Why? Because Coriolis force is going to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. Upper layer in the southern hemisphere, giving rise to net transport, giving rise to net transport, which becomes 90 degrees to the wind direction, which becomes 90 degrees to the wind direction, giving rise to the Ekman's spiral or transport. Giving rise to the Ekman's spiral or transport. Again, don't draw this diagram. Giving rise to the Ekman spiral or transport. ये पानी है. This entire is water. This is the upper layer, 45 to the direction of the wind. This is the lower layer. Right कितने deflection हमें पता नहीं, हमें सिर्फ पता है right में to the upper layer. उसके नीचे का layer right to this layer. उसके नीचे का layer right to this layer. So ultimately पानी ऐसे घूमेगा, and therefore wind direction and Ekman transport का direction will be different. Getting it? Getting it? अब एग्जाम में अगर ऐसे आता है तो what you are going to write? You are going to write that is the pressure starting का Coriolis force, wind direction and velocity will give rise to the circulatory motion, which is different from the wind direction. Wind affects the by the friction only up to the depth of 100 meters, but as the at the successive depth the velocity goes on decreasing due to friction. The upper layer moves at 45 degrees to the direction of the wind. Because of the upper layer moving, the lower layer will start moving, but at a lesser velocity, and therefore there will be lesser deflection. Thus the successive layers of the oceans up to the depth of 100 meters will move with different velocities, but the deflection will keep on decreasing. Due to the Coriolis force, in the northern hemisphere, the deflection of wind, surface current, subsurface currents will be to the right of each other and to the left of each other in the southern hemisphere. And therefore, the net result is the water will start moving perpendicular to the wind direction, which is known as Ekman's transport. Finish. Getting it? Very simple. राइट में ही रहेगा ना, तो डायरेक्शन तो राइट में ही होगा, कितना डिफ्लेक्शन है वो चेंज होते जाएगा. सो अगर विंड का डिफ्लेक्शन चेंज हुआ तो इसका डिफ्लेक्शन 45 डिग्री चेंज होगा. यस, 45 डिग्री. इसीलिए तो देखो विंड ऐसी जा रही है, डिफ्लेक्शन ज्यादा हो रहा है, डिफ्लेक्शन ज्यादा हो रहा है. फाइन. तो करंट ऐसा डिफ्लेक्ट हो रहा है. आई विल यूज डिफरेंट पेन. करंट ऐसे डिफ्लेक्ट हो रहा है, गल्फ स्ट्रीम, फिर ऐसे डिफ्लेक्ट हो रहा है, फिर ऐसे डिफ्लेक्ट हो रहा है, फिर ऐसे डिफ्लेक्ट हो रहा है, फिर ऐसे डिफ्लेक्ट हो रहा है. तो हम क्या करते हैं, गल्फ स्ट्रीम, नॉर्थ अटलांटिक ड्रिफ्ट एंड देन कोल्ड करंट इन द फॉर्म ऑफ कैनरी करंट, और इसी को तो हम गायर कहते हैं. गेटिंग इट? कौन सा मतलब? कैसे? 3D में डायग्राम देखना है. पेज नंबर 225 ऑफ योर बुक which I have shared on the telegram. This is what is the Ekman spiral. Direction of wind, green color. Direction of ocean current. Surface current, subsurface current, subsurface current, subsurface current, subsurface current. Cone नहीं बनेगा. It will be straight. Why it will be cone like? This is the way we are making the diagram. Don't go by this diagram. What you have studied the Ekman spiral is on the climate. देखो Ekman spiral के पास हम फिर से आएंगे. हवा जब भी ऊपर जाएगी, it is due to the Ekman spiral, हवा ऐसे ऊपर नहीं जाती हमेशा. It goes in this manner because of the difference in the frictional forces. Similarly, Ekman spiral below. So don't apply the climate logic here. Not at all. It is not conical. Why it will be conical? It is the huge mass of water, cylindrical, which is moving. Cylindrically chalega, it will never be conical. Next point. Don't apply physics to geography. Geography is social science. Physics is in the laboratory. Geography is in the real life. अगर रियल लाइफ में जो थेरोटिकल है कभी एज इट इज अप्लाई नहीं होता, राइट? यू आर नॉट इन द लैबोरेटरी. हैड यू बीन लैबोरेटरी, अगर फिजिक्स सही होता तो मैं आपको कहता ये ऑप्शनल लो, ये बुक पढ़ो, ये टेस्ट सीरीज ज्वाइन करो, ये ऐसे करो, ये ऐसे करो, सिलेक्शन पक्का है. ऐसे होता है कभी? बिकॉज दिस इज रियल लाइफ. कोई पढ़ रहा है सविंद्र सिंह, कोई पढ़ रहा है खुल्लर, कोई कुछ भी नहीं पढ़ रहा है, सिर्फ नोट्स पढ़ के जा रहा है. हर एक के रिजल्ट्स अलग है. दिस इज द रियल लाइफ. फाइन. थियरी डज नॉट अप्लाई. थियरी डज नॉट अप्लाई, इसलिए आप ट्रायल एंड एरर करते रहते हैं. एक अटेम्प्ट में ये टेस्ट सीरीज लगा ली, दूसरे अटेम्प्ट में वो टेस्ट सीरीज लगा ली. फायदा किससे हुआ है? फायदा हुआ है जो 3-4 साल आपने पढ़ाई की है उससे, किसी एक टेस्ट सीरीज से नहीं, किसी एक क्लास से नहीं. बट हमेशा कौन क्रेडिट लेगा? जो फर्स्ट वाला है या जो लास्ट वाला है? फर्स्ट वाला कि मैंने इसको पढ़ाया था, लास्ट वाला कि हमारी टेस्ट सीरीज लिख के ये क्लियर हुआ. फाइन. किसी से कुछ नहीं होता, सब कुछ आप करते हो. अंडरस्टैंडिंग? डोंट बी, देखो इट इज इकोनॉमिक लॉस फॉर मी. डोंट बी एवर इन द दिस थिंग कि ये क्लास लगाने के कारण मैं पास हो जाऊंगा. क्लास सिर्फ आपको गाइडेंस देगा. इस सब्जेक्ट में आपको नोट्स दूंगा, आप पास होगे अपनी मेहनत से, और मेहनत आप हिट एंड ट्राई करके ही करोगे. There is no fixed. How many times you have made a timetable and changed it on the next day? This is not physics. This is not science. This is humanities. So next point. The theoretical model of the Ekman spiral. The theoretical model of the Ekman spiral does not always take place at 90 degrees. Does not always take place at 90 degrees, but it varies between 60 to 90 degrees. But it varies between 60 to 90 degrees in reality. In reality. Varies between 60 to 90 degrees in reality. Ekman ने कहा it should take place at 90 degrees, but reality में it will vary between 60 to 90 degrees. Draw this diagram with me. If you are planning to buy a laptop, buy Surface, उससे अच्छा. If you are planning to buy a laptop, I am saying buy the instrument I am having now. 60,000 का है अभी तक. बिकॉज इसमें बहुत सारे फायदे हैं. स्केल, सर्कल, सब कुछ आ जाएगा. आईपैड में भी चलता है. What is this? This is water. No need of drawing the blue lines in the exam. Just should know that water body. The same diagram. The only thing is exam में एक दो ही पेन से, एक जगह से wind, एक जगह से Ekman transport, black pen से surface current, blue pen से subsurface current. ये इसके बाद और एक लाइन है. Subsurface, this current will be to the right of this current. This current will be to the right of this current. This current will be to the right. This current will be to the right. ये इस साइड खींच रहा है, ये इस साइड खींच रहा है, इसलिए तो 90 डिग्रीज में जाएगा पूरा surface water. Understanding? Deviation, even if it is more than 90 degrees here, and if it is pulling in this direction, it is pulling in this direction, then only the forces will be balanced and water will move in this direction. $225. Ekman. Diagrams are given in this book. Explanation is given in Savindra Singh Oceanography. This explanation is not that good. But diagram here लिखना, explanation जो हमने किया is more than enough. No, ऊपर का लगा, ऊपर का. Ripple effect क्यों create होता है? Wind will take the surface water. सरफेस वाटर मूव करेगा तो नीचे का पानी डिस्टेबलाइज होगा, फिर नीचे का पानी डिस्टेबलाइज होगा और फिर पानी में रिपल इफेक्ट होगा. Least importance from the exam point of view. Now, why Ekman's spiral is important? Our answer is not important, okay? Not finished yet. An imaginary continent. Westerlies. And easterlies. That is the trade winds, right? East to west, west to east. Water will come perpendicular और बनेगा यहाँ पे कहीं तो warm current, यहाँ पे बनेगा कहीं तो cold current. It is always perpendicular to the wind direction. Understanding? Cold currents and warm currents क्यों generate होते हैं? And when they come near the coast, they will upwell or downwell. That is the next point. Understanding the Ekman's transport. Understanding the Ekman's transport is important for upwelling and downwelling. Is important for the upwelling and downwelling. Is important for upwelling and downwelling. Now we have not done climatology, but if you have done climatology even in GS या पहले, you already know the heat is सबसे ज़्यादा at the equator because the sun is exactly located over the equator. Because heat is maximum at the equator. If this is ground, due to heating, यहाँ की हवा ऊपर जाती है, right? So we say this is a low pressure belt. यहाँ की हवा ऊपर जाती है, इसलिए the winds from the surrounding region will come to the low pressure belt and they will also start rising upwards. Therefore, we will call this as ITCZ, Intertropical Convergence Zone. Now this is the ITCZ. This is how the trade winds are coming from the northern and southern hemisphere. Right? Clear? ITCZ. Understood what is ITCZ? Wind ऐसी है. Ekman transport says that currents always flow perpendicular to the wind direction, to the right in the northern hemisphere, to the left उस direction में in the southern hemisphere. So इसलिए Ekman transport gives rise to equatorial current. Understanding? Ekman's transport gives rise to the equatorial current. Equator पे थोड़ी wind ऐसे जा रही है. Why equatorial counter current? Why equatorial north and south equatorial current are generated? It is due to the Ekman transport, perpendicular to the wind direction. Wind is not flowing. The wind ऊपर से लेके wind तो ऐसे जा रही है. Currents are going this. Have you done? Understood? जिन्होंने GS में पढ़ा है, understood climate? Understood? Equatorial current generate होते हैं. Look at the first point. हमने 3 point रखे हैं. Westerly intensification. Because of the Ekman transport, equatorial water is taken from east of the ocean to the west. And इसलिए यहाँ पे बहुत ज़्यादा पानी इकट्ठा होता है. That is westerly intensification. And then यहाँ पे जाके winds उसको दूसरे direction ले जाएगी. That is the next point. Ekman's transport gives rise to west to east, east to west. Ekman transports gives rise to east to west circulation of surface water near the equator. Circulation of surface water near the equator, which converges on the western part of the oceans forming not oceanic, water hills. Water hills मतलब piling up of water. जानबूझ के technical tough बनाया subject को, causing piling up of water. Fine. Textbook अगर पढ़ोगे, westerly intensification results into formation of water hills and water valleys. Then the water flows from hills, when the ocean currents flow from water hills to valleys after westerly intensification. मतलब इसका कहना क्या है सिंपल वर्ड्स में कि यहाँ पे पानी बहुत ज़्यादा इकट्ठा हो गया, इसलिए पानी का लेवल बढ़ गया, वाटर हिल, और पानी का लेवल कहाँ कम हुआ, इस साइड में, एंड इसीलिए हिल से वैली एंड काउंटर इक्वेटोरियल करंट इज जनरेटेड. गेटिंग इट? सो दैट इज व्हाई आई एम सेइंग नो नीड ऑफ बाइंग एनी टेक्स्ट बुक एक्सेप्ट फिजिकल ज्योग्राफी. बाकी का थिंग्स आर वेस्टर्ली इंटेंसिफिकेशन. सविंद्र सिंह में 4 पेजेस में दिया है, कुछ नहीं समझ में आएगा एक रीडिंग में, 2-3 साल लगेंगे समझ में आने के लिए. यू डोंट हैव दैट मच टाइम. वाटर हिल्स एंड देयरफॉर counter equatorial current is generated. Counter equatorial current is generated which flows from west to east, in the oceans. Similarly, piling up of water, results into north south divergence of the ocean currents in the form of warm currents, north south divergence of the ocean currents in the form of warm currents. एग्जाम्पल किसकी बात कर रहा है? काउंटर इक्वेटोरियल करंट जनरेट हुआ, फिर गल्फ स्ट्रीम एंड ब्राजीलियन करंट. एग्जाम्पल गल्फ स्ट्रीम एंड ब्राजीलियन करंट. So ये पानी look here ऊपर चला गया, फाइन, इवन इन द ट्रेड विंड बेल्ट, बिकॉज यहाँ पे कॉन्टिनेंट है, और एक बार ऊपर गया इट कम्स अंडर द वेस्टर्लीज, वेस्टर्लीज के साथ साथ डिफ्लेक्ट होगा, और जब वेस्टर्लीज ऐसी जाएगी ये 90 डिग्रीज को डिफ्लेक्ट होके ये फिर से नीचे आएगा एज कोल्ड करंट. गेटिंग इट? एंड दिस इज व्हाट इज गायर, सर्कुलेशन गायर. फाइन, दिस इज अंडरस्टूड इक्मेंस ट्रांसपोर्ट. एंड उसका सिग्निफिकेंस इज करंट्स समझ में नहीं आएंगे जब तक इक्मेंस ट्रांसपोर्ट यू डोंट अंडरस्टैंड. अदरवाइज क्वेश्चन ये होगा कि इफ द वेस्टर्लीज आर ट्रेड विंड्स आर मूव कन्वर्जिंग एट ITCZ from northeast to southwest or from southeast to northwest, then why currents are flowing from east to west? Currents भी ऐसे ही आने चाहिए थे, but Ekman transport says कि currents always be are perpendicular to the wind direction. और एक बार इक्वेटोरियल करंट जनरेट हुआ तो there is piling up of water से getting it? अब लुक एट 2012 का प्रीलिम्स का क्वेश्चन. टेल मी, $2010 या 2012 का? What is the answer? Winds. Rotation of the earth is not. It is the winds which generates equatorial current. Equatorial current एक बार जनरेट हो गया तो फिर पूरा प्रोसेस शुरू होता है. इक्वेटर का पानी निकल गया, वो बन गई गल्फ स्ट्रीम, वो बन गया काउंटर इक्वेटोरियल करंट, वो बन गया ब्राजीलियन करंट, और फिर बिकॉज इक्वेटर का पानी निकल गया इसलिए ऊपर से कोल्ड करंट्स विल कम नियर द इक्वेटर. So which is the single most important factor? It is the winds. By rotation of the earth. नहीं, बिल्कुल नहीं. रोटेशन ऑफ द अर्थ के कारण होता ही नहीं इक्वेटोरियल करंट. जीएस में आपको लगता है मैं इक्मैन स्पाइरल पढ़ाऊंगा? अभी भी फिर से दोज हु आर गोइंग टू अटेंड माय जीएस मैं ये कहूंगा, देखो रोटेशन होगा इसलिए देयर विल बी इक्वेटोरियल करंट. फाइन, जरूरत ही नहीं इक्मैन स्पाइरल की उनको. यस, सिंगल मोस्ट इंपॉर्टेंट एक ही चूज करना, अदरवाइज ऑल आर इंपॉर्टेंट फैक्टर्स. ऑल आर द फैक्टर्स यू हैव टू चूज सिंगल मोस्ट. और मैं जीएस में ये लिखता, ये भी यही डिस्कस करूंगा कि अगर क्वेश्चन आता है विच इज द सिंगल मोस्ट इंपॉर्टेंट फैक्टर, हमेशा विंड्स मार्क करना, क्योंकि जीएस में क्यों डाउट नहीं पूछेगा. मैं उनको एग्जांपल दूंगा, देखो कल ये किसको लेके जा रहा है, विंड से लेके जा रही है, ये किसको लेके जा रहा है, विंड से लेके जा रही है, ये क्यों आ रहा है, विंड से ले आ रही है, खत्म जीएस. राइट, Wind ka circulation is due to wind ka circulation is due to temperature difference, pressure difference, right? Done with the ocean currents? Fine. Ocean deposits, very, very important topic. Every alternate year, one question comes from the ocean deposits. We are coming to the end of oceanography. I require 2.5 lectures for oceanography. Ocean deposits, ocean resources, and coral reefs. Fine. Tides. Oh, 10 मिनट का काम है. Tides. Two and a half मतलब 3 lectures. Now look. Continental shelf, slope, etc. And this is the oceanic bottom. Now, when we say ocean deposits, usse pehle we should understand what are the ocean biomes. So, when we do the ocean biomes, there are two kinds of ocean biomes. One kind of an ocean biome is what is known as neritic biome or what is known as an littoral biome. Littoral biome isliye because it is nearby the continents. It is the outer part of the continents. And this kind of an biome, which is what is known as an pelagic biome. Pelagic biome is obviously the biome that is present in the open sea. जो continent का part नहीं है, जो oceanic crust का part है, this is what is known as an pelagic biome. Pelagic biome has photic zone and as well as a photic zone. Photic zone मतलब जहां तक sunlight will reach, and aphotic zone means जहां पे there will be no sunlight. Getting it? This aphotic biome is further divided into mesopelagic, epipelagic. I am not drawing the epipelagic as well as benthic community. Up depending upon the questions, if the question comes on the biomes of the oceans or the layers of the ocean below the sea water, आप ये नहीं लिखोगे benthic. You will write bathypelagic. But if the question comes regarding the biomes in the ocean or the ocean deposits or ocean ecosystem or the oceanic life, chapter 3 and 4, chapter 4 and 5, उसमें आप लिखोगे this as a benthic community. One who live on the ocean depth and this is the bathypelagic biome. Pelagic is further divided into. So ये जो topic है generally students छोड़ के जाते हैं because they find it very tough. It is not at all tough. It is thus that इसमें factual data थोड़ा ज़्यादा है. It is not at all conceptual. Getting it? यहाँ पे most of the sediments जो होंगे, they will be terrigenous. What they will be? Don't write anything. This is not the diagram you should draw. I will tell what diagram to draw. First try to understand. यहाँ पे most of the sediments will be terrigenous. Terrigenous means they have come from the territory, that is the land. यहाँ पे most of the sediments will be of two types, either in the which comes from the oceans only, or which come from the extraterrestrial, that is comets गिर, meteors गिर गए, और कुछ extraterrestrial object गिर गए, and this will be the kind of sediments, and therefore यहाँ पे most of the sediments will be in the form of oozes. इसलिए ये टफ लगता है. Now what is oozes? Oozes is nothing but dead and decomposed organic matter. कोई fish अगर यहाँ मर गई, कोई humans मर गए, कोई कुछ हुआ यहाँ पे, तो ये सारा नीचे नीचे जाके यहाँ पे इकट्ठा हो जाएगा. It will come down here. It may become the food of the living organisms, or it may become the biomes. Getting it? यहाँ पे most of the sediments will be which are brought by the rivers, and therefore terrigenous sediments. Getting it? Ocean deposits, the chapter is there in the Savindra Singh also. If you want, you can read it. We will divide it into three parts. Just before that, open the past year question booklet. I just want to tell you how the questions are. Come to the first question of oceanography. The first question in the entire oceanography was, write a short note on pelagic deposits. नहीं, pelagic deposits. Photic, mesopelagic, bathypelagic, epipelagic deposits कौन सा मिलेगा, red clay कहाँ मिलेगा, silica कहाँ मिलेगा, और oozes obviously. Yes, we will understand this. Decomposed matter. Second, इसी टॉपिक का क्वेश्चन है, ocean deposits and ocean resources. Second is, give an account of marine resources and discuss their present day utilization. If you understand where are the deposits, if you understand what are the biomes, you will understand what are the resources. Question number 11, 97 में, marine resources, biotic minerals and energy resources. लगता है GS का question है. If you write GS का answer, you will not get marks. Your answer should be bit technical. That is, अब you can you understand कि ocean currents के conclusion में, even if the Ekman spiral is not asked, you will have to mention the Ekman spiral. That is, most of the ocean currents flow perpendicular. और वो diagram बना दो, Ekman spiral एक point extra हो गया. Again, 2004 में write a short note on the pelagic deposits. UPSC का favorite है pelagic deposits. 21 में थोड़ा deep में गए, question number 21 में वो 2007 में, discuss the different bases for classifying the ocean deposits and give a detailed account of the pelagic deposits of the oceans. फिर से कहाँ पे आए? Pelagic deposits. 60 marks के लिए. Different bases. If there is a continental shelf, if there is a shallow zone, if the basis is of the continent, it is known as an littoral zone. If it is an open sea, it is known as pelagic biome. Depending upon the intense amount of light, it can be divided into photic and aphotic. Aphotic biome is further divided into epipelagic, mesopelagic, bathypelagic. Bathypelagic is the deepest part. Fine? Different bases. फिर से 2010 में write a short note on ocean deposits. You are classifying it on the basis of layers only. That is what is the different basis. Yes. Question number 2012 का, write a short note on the different layers of the ocean water above the abyssal plain. Which is the abyssal plain? The deepest part. मतलब indirectly उन्होंने फिर से pelagic layer के बारे में question पूछा है. Write a short note on the, सिर्फ language change कर दी, पहले direct पूछते थे, अब indirect पूछ रहे हैं. Getting it? 38, 2015. Describe the characteristics of different types of pelagic deposits. And last was open-ended questions, that is describe the potential marine energy resources with reference to the benefits, harvestability and environmental impacts. Describe the potential marine energy resources. I am not discussing, I am not taught you anything, you have studied GS, tell me what are the marine energy resources. क्या लिखोगे इसमें? क्या लिखोगे इस आंसर में? What are the quick points? Because ocean deposits, ocean resources एक ही टॉपिक है, हम दोनों एक ही साथ करने वाले हैं. So tell me, answer to that question. Last question जो पिछले साल का था. Describe the potential marine energy resources with reference to their benefits, harvestability मतलब कितना यूज कर सकते हो, and environmental impacts. क्या क्या आता है एनर्जी रिसोर्सेस? टाइड्स. इसमें आप फॉसिल फ्यूल्स लिखोगे, पेट्रोलियम लिखोगे, फिर से क्वेश्चन पढ़ो. एक ये मिस्टेक है, पोटेंशियल वो की पॉइंट है. अंडरस्टैंडिंग? नॉट द ऑलरेडी विच आर प्रेजेंट, जो आगे डेवलप कर रहे हैं. ये मिस्टेक्स होती है एग्जाम में. हमें लगता है हमने बहुत अच्छा आंसर लिखा और आपने सब फॉसिल फ्यूल्स लिखा, आपने सब लिखा, वहां लिखा. दैट इज नॉट द डिमांड ऑफ द क्वेश्चन. द डिमांड ऑफ द क्वेश्चन इज टाइडल एनर्जी, वेव एनर्जी, ओटेक, करंट, ओशन करंट बेस्ड एनर्जी, गैस हाइड्रेट्स. गेटिंग इट? दिस इज व्हाट इज द क्वेश्चन. कब आया था? 2018. Why? Last year we had discovered gas hydrates in the oceans. This is the demand of the question. Geothermal energy, not the energy that is already present. उसका benefit क्या है? इंडिया के examples ही ले सकते हो, उसके impacts क्या है? Getting it? Therefore, each and every point of the question should be well read. So ocean deposits, you can take down. Oh, sorry, I have not taught you upwelling and downwelling. I'm sorry. सब सरफेस को पढ़ने की जरूरत नहीं. सब सरफेस पढ़ने की जरूरत नहीं, सब सरफेस इसलिए पता होना चाहिए. If this is the surface layer, this 500 to 1000 meters is subsurface layer, and यहाँ पे टेम्परेचर ज़्यादा है और यहाँ पे टेम्परेचर कम है. यहाँ पे सैलिनिटी ज़्यादा है, यहाँ पे सैलिनिटी ऑब्वियसली ज़्यादा है. वी डोंट नो, बट कैन आई से दिस इज द रीजन विच इज लेस डेंस and this is the region which is very dense. Why? Because it is cold as well as saline. Understood? So when we say surface currents, we are saying these are the surface currents, but there is another current system which is known as the subsurface current, and this is the thermohaline circulation, which occurs just below the thermocline layer or halocline layer. मतलब which occurs below the region जहाँ पे temperature difference is greater और जहाँ पे salinity difference is greater. This thermohaline circulation starts from the polar regions. Getting it? This thermohaline circulation starts from the polar regions and it is most strongest in the Antarctic, in the Atlantic Ocean. ये हमारे syllabus में बिल्कुल नहीं है, हमें करना भी नहीं है ये. But why I am telling you? Because you will not understand upwelling without this. Getting it? So understand this as a world map. No need of drawing this world map. Atlantic, Indian, Pacific. गैप कम है नियर द बेरिंग स्ट्रेट, है ही नहीं. सबसे ज्यादा गैप है in the Atlantic Ocean. So therefore it starts in the Atlantic Ocean and it starts, this deep ocean water starts coming downwards. It is very very strong in the Atlantic and it takes all the deep waters and it comes and it moves in the Indian Ocean also. Indian Ocean का भी deep water move करता है, Pacific का भी deep water move करता है and because the deeper water moves, surface पे the warm water moves. So ocean currents in our syllabus जो हमने पढ़ा है अब तक is only the surface current. We don't have thermohaline circulation. हमारे syllabus properly पढ़ो, वहाँ पे दिया है ocean currents. वहाँ पे बिल्कुल word नहीं है thermohaline circulation. These are not known as ocean currents. These are known as thermohaline currents. But what happens is this thermohaline circulation starts from Atlantic, it moves towards Indian Ocean. Indian Ocean का ठंडा पानी mix होता है, it moves in this direction, it does not come in the northern Indian Ocean and then it starts moving and वो जाता है even in the Pacific. To compensate the water that is lost, therefore we find warm currents moving. We find warm currents moving. We find warm currents here moving. यहाँ पे कोई पानी mix नहीं होता है इसलिए surface water moves only with the winds. Fine. अब ये कभी कभी ये cold water when it comes near the coastline it will start upwelling. This warm water when it goes in the polar regions it will start downwelling and इसी को हम कहते हैं gyre. So there are two kinds of gyre. एक है surface gyre जिसको हमने दिया है नाम subtropical gyre. इस tropic, subtropics and temperate region से how the current is moving. एक है circulatory gyre मतलब surface currents and subsurface currents कैसे move होते हैं. Understood? हमें करने की जरूरत नहीं है. There is not mentioned in our syllabus. We are going to do upwelling and downwelling. So, introduction. जो हम पढ़ते हैं, they are only surface currents. Yes. उनके नीचे is the thermo. Remember, if you remember the first class of ocean currents, day before yesterday, मैंने कहा था only 10% of the water will move as a surface current. 90% of water in the ocean moves as thermohaline circulation below the depth of 1000 meters. हमने आज कहाँ तक पढ़ा? Only up to the depth of 100 meters. Surface current. Cold currents, warm currents. Cold currents and warm currents are at the surface. They are mixing. इसीलिए हवा मिक्स हो रही है. सब सरफेस करंट्स का कोई इम्पैक्ट नहीं है बट सब सरफेस करंट ही वार्म करंट्स को जनरेट करेंगे और वो ऐसे सर्कुलेटरी गायर में मूव करेगा. कोल्ड एंड वार्म करंट सरफेस करंट, उसके नीचे थर्मोहलाइन लेयर 500 से 1000 मीटर्स के बीच और उसके नीचे थर्मोहलाइन सर्कुलेशन 1000 मीटर्स के नीचे. Totally different. You don't study thermohaline circulation. You don't study this map, which I told you on page number 250. You study only the surface current, fine? You study only this circulatory gyre. You don't study thermohaline circulation. Getting it? You don't study this. You don't study what are the deep ocean currents. You don't study this. Fine? So, मैं इसलिए बोल रहा हूँ because I am introducing the introduction, giving you in the introduction. The global ocean circulation model, the global ocean circulation model, the global ocean circulation model is also known as conveyor belt circulation. Is also known as conveyor belt circulation. उसको क्या कहते हैं? गायर, जो सिर्फ सरफेस पे घूम रहा है. कन्वेयर बेल्ट क्या है? ऊपर नीचे घूमता है. एयरपोर्ट का बेल्ट, conveyor belt circulation. This circulation causes exchange of surface water mass and deep ocean water mass by the process of downwelling and upwelling. जहां पे बेल्ट नीचे जा रहा है डाउनवेलिंग, जहां पे बेल्ट ऊपर आ रहा है अपवेलिंग. Downwelling and upwelling. Getting it? We are saying upwelling of Benguela current, upwelling of Humboldt current. ये confuse हो रहा है तुम्हें? Current starts as Labrador current, as a surface current. It is extremely cold. It is coming to the tropics. It is mixing with the Gulf Stream. थोड़ा वार्म हो जाता है, बट वो मेजरली कोल्ड है. फिर वो ट्रॉपिक्स में आ रहा है. ये पानी कोल्डर है, ट्रॉपिक्स का पानी वार्मर है, वो बन जाएगा डीप ओशन करंट. अंडरस्टैंडिंग? ट्रॉपिक्स में आते ही वो डीप ओशन, इट स्टार्ट्स एज अ सरफेस करंट, फिर आते आते वो बन जाता है डीप ओशन करंट. फिर वो बन जाता है, जब हम डीप ओशन करंट कहते हैं, वी कॉल इट एज अ कैनरी करंट. फिर वो स्ट्राइक करता है अफ्रीका को स्ट्राइक करके वो ऊपर आता है अपवेलिंग. गेटिंग इट? It gets warmer, but it is comparatively more colder than the sea temperature in the tropics. So it downwells. Climb layer. Understood? His doubt was very logical. His doubt was कि हम कहते हैं upwelling of Humboldt current, upwelling of Benguela current, ये तो surface currents है. Then why we call it as an upwelling? फाइन, क्योंकि अपवेलिंग तो अभी हमने लिखा है कि ये डीप ओशन करंट का हो रहा है. रिमेंबर, कोई भी करंट इन द पोलर रीजन विल स्टार्ट एज अ सरफेस करंट. वो बहुत ठंडा है. सो वो जब 30-35 डिग्री लैटिट्यूड्स पे आता है, जहाँ पे सैलिनिटी ज्यादा है ड्यू टू इवेपोरेशन, जहाँ पे ये भी बहुत ज्यादा है, टेम्परेचर भी बहुत ज्यादा है, सो ये ठंडा पानी सिंक होने लगता है एंड वो सरफेस करंट बन जाता है डीप ओशन करंट. कितना सिंक होता है वो? 1000 मीटर्स के नीचे. फिर वो कम्स एंड हिट्स द कोस्ट. नियर द डेजर्ट्स, और फिर वो नीचे से ऊपर आता है, नीचे से ऊपर आता है, सारे न्यूट्रिएंट्स लेके आता है नीचे से। गेटिंग इट? गल्फ स्ट्रीम गर्म है, सरफेस करंट करके जाता है, गर्म पानी सारे न्यूट्रिएंट्स लेके जाता है, फिर वो बन जाता है नॉर्थ अटलांटिक ड्रिफ्ट, देन इट बिकम्स नॉर्वेजियन करंट। रिमेंबर, when it goes as a Norwegian current, this warm water becomes colder till the time it reaches there. As it reaches there, when it becomes extremely cold, plus it is more saline because it is coming from the tropics, वो बन जाता है deep ocean current. इसी को हम कहेंगे conveyor belt model. Downwelling is occurring in the polar regions, upwelling is occurring in the tropical regions. Getting it? This is what is deep ocean currents. Fine? Understood? Next, downwelling. What is downwelling? Downwelling is the process of, it is the process of sinking of, underline उसके बाद dense surface water in vertical manner. Dense surface water in vertical manner. कौन सा कैसा होना चाहिए? डेंस। क्यों होगा डेंस? क्योंकि कुछ भी हो सकता है फैक्टर, बोथ सैलिनिटी एंड टेम्परेचर, और इधर सैलिनिटी और टेम्परेचर। गेटिंग इट? सैलिनिटी ज्यादा है तो डेंसिटी ज्यादा हो सकती है, टेम्परेचर कम है तो डेंसिटी ज्यादा हो सकती है, या कोई भी दोनों फैक्टर्स कंबाइन हो सकते हैं। इट इज ऑल, you should know that is, it is all in comparison to that level of water, not general idea. कंपैरेटिव एनालिसिस है, ऊपर का पानी का 1 डिग्री सेल्सियस टेम्परेचर, नीचे के पानी का टेम्परेचर 0 डिग्री सेल्सियस है, तो नीचे का पानी ज्यादा डेंसर हो गया। गेटिंग इट? द डेंसिटी डिफरेंसेस होता है, आइसबर्ग के नीचे का पानी वैसे ही होता है, इसलिए वाटर डज नॉट फ्रीज इवन इन द पोलर रीजन, सिर्फ आइस फ्रीजेस ऊपर का लेयर। नेक्स्ट पॉइंट, downwelling occurs, the density difference may be due to salinity or temperature, salinity or temperature, salinity ज़्यादा, temperature कम, that is due to more salinity or less temperature. Next point, downwelling occurs only when pycnocline layer, only when the pycnocline layer is absent. Is absent. अब ये लेयर क्या है? पढ़ना नहीं है, सिर्फ समझ में आना चाहिए। What is thermocline layer? जहां पे टेम्परेचर सडनली डिक्रीजेस। व्हाट इज हेलोक्लाइन लेयर? जहां पे सैलिनिटी सडनली चेंज होता है। व्हाट इज पाइनोक्लाइन लेयर? जहां पे डेंसिटी सडनली चेंज होता है। गेटिंग इट? पहले समझ लो इसको, ऊपर का लेयर ऑफ सरफेस वाटर अप टू 500 मीटर्स इज लेस डेंसर, ऑब्वियस, क्योंकि इसका टेम्परेचर ज्यादा है। 1000 meters के बाद it is very cold. It can be saline also because of brine rejection, and therefore it is more denser. So scientist कहते हैं वही thermocline और halocline layer, when we study in the terms of density, then it is known as pinococline layer. जहाँ पे ऊपर का लेयर इज लेस डेंसर, पीछे का लेयर इज मोर डेंसर. डाउनवेलिंग कब होगा? जब ये लेयर एब्सेंट है. अगर ये लेयर प्रेजेंट है तो नीचे का पानी बहुत डेंसर है, वो डाउनवेलिंग होने नहीं देगा. गेटिंग इट? डाउनवेलिंग के लिए this layer should be absent, that is there should be more or less same density, because if this is less denser then there will be no downwelling, it will stop the downwelling. Understanding? Next point. See, that is why I have not taught you density differences. Density मैंने बताया था temperature, salinity and density. Density का सिर्फ application पता होना चाहिए. They will not ask you thermocline and halocline जैसा pinococline layer. Pinococline layer क्या है? The layer below which there is sudden increase in the density. Pinococline layer. Downwelling can be due to density. Downwelling can be due to density. Or due to convergence of surface ocean currents. Or due to convergence of surface ocean currents. Convergence of surface ocean currents. It can be due to density differences or due to convergence of surface ocean currents. It's very easy. सिर्फ घर पे जाके एक बार पढ़ लो. क्लास में समझाते समय आपको डिफिकल्ट लग रहा है, मेरे एग्जाम्पल से याद रखो. What happens in the plate tectonics? The two plates collide and the plate which is having more density is subducted. What happens in the convergence of surface ocean current? Warm Gulf Stream collides with cold Labrador current. So warm Gulf Stream is Sial, continental crust. Cold Labrador current is oceanic crust. वैसे याद रखो तो Labrador current नीचे चला जाएगा. Getting it? Fine. उसकी भी डेंसिटी पड़ेगी. तो you can take down the convergence causes collision of warm and cold ocean currents. Collision of warm and cold ocean currents. And similar to the plate tectonics, the cold currents down wells. Cold current down wells. Impact of downwelling or importance of downwelling. Impact or importance of downwelling. Downwelling of surface water. Downwelling of the surface water. Downwelling of the surface water transports oxygen downwards, which is much needed by which is much needed by deep living marine organisms, which is much needed by deep living marine organisms. Point number 2, but such downwelling, but such downwelling, such downwelling discourages, discourages marine, surface marine life, surface marine life and fishing, and fishing, surface marine life and fishing. Clear with this? क्यों फिशिंग एक्टिविटी के लिए बुरा है? जीएस के लिए याद रखना डाउनवेलिंग, बिकॉज इट टेक्स ऑल द न्यूट्रिएंट्स below. Why upwelling is good? Because it brings all the nutrients above. Fine, you can go for GS because मैं upwelling का कुछ pointers, I'll finish the upwelling now. Upwelling, refers to reappearance, refers to reappearance of cold water from the ocean depth, of the cold water from the ocean depth. Upwelling is generally divergence dependent. Upwelling is generally divergence dependent and Ekman transport dependent, and Ekman transport dependent. Generally divergence dependent and the Ekman transport dependent. Why Ekman transport dependent? कि अगर Ekman transport से winds do not cause equatorial currents, तो there will be no upwelling. Equatorial currents ऐसे move हो रहे हैं, इसलिए नीचे का पानी ऊपर आ रहा है. And next point, the trade winds, the trade winds, the trade winds diverge or move away. Divergence मतलब moving away. The trade winds diverge or move away the surface water from the equatorial regions, the surface water from the equatorial regions. किसकी बात कर रहा है? In the form of which currents? Equatorial currents. This causes deficit, this causes deficit on the eastern side of the oceans. This causes deficit on the eastern side of the oceans. As a result of which upwelling of cold water, upwelling of cold water from below occurs. Upwelling of cold water occurs. Upwelling may also be caused, next point, upwelling may also be caused when winds move away, when the winds move away water from the coast. When the winds move away water from the coast. Such kind of upwelling, such kind of upwelling is seen in the desert regions. Where the trade winds are offshore. Where the trade winds are offshore. You can draw this diagram. Understanding? नीचे से पानी ऊपर आ रहा है because deficit create कर रहा है. सिमिलर अपवेलिंग कहाँ होगा? वेस्टर्लीज जब ऑफशोर हो जाएगी, इसलिए लैब्राडोर करंट ठंडा है. Fine. I'll stop here. Maybe there is a class. Benefit एक ही है. What is the benefit? Bring nutrients on the surface. So benefit, it brings dissolved oxygen. It brings dissolved oxygen and nutrients. सिर्फ दो. तो यूपीएससी ने पास्ट ईयर पूछा है बॉटम ड्वेलिंग ऑर्गेनिजम्स भी लाता है क्या? नहीं, सिर्फ क्या? डिसॉल्व्ड ऑक्सीजन्स एंड न्यूट्रिएंट्स on the surface, thus supporting rich marine life, and therefore these regions are beneficial for fishing. Therefore these regions are beneficial for fishing. Example, due to upwelling of cold Humboldt current. Fine. So tomorrow we'll start with the ocean deposits. Very easy topic. I'll give you a handout so that आपको ज़्यादा easy हो जाएगा for the ocean deposits.